Alright, so problem 25, we have a lecture hall that has 200 seats with folding arm tablets, 30 of which are designed for left-handers. The average size of the class there is 188. We can assume that about 13% of students are left-handed. What's the probability of a right-handed student in one of these classes forced to use a lefty arm tablet? Okay. So here's what we know. We have 200 seats. 30 are lefty, 170 are righty, 188 is the average size of the class, and 13% are left-handed. Okay? So I'm going to do this problem two ways, okay? There are 170 right-handed seats, okay? So if the 171st person walks in, there's 171 righties, then one person has to sit in a left-handed desk. So we got to find the probability of 171, or 172, or all the way up to 188. That's the average class size, okay? Well, how do we do this? How do we sum this? Well, we do this as 1 minus the probability of no righties all the way up to the probability of 170 righties. Okay? Well, how do we do that? That's binom CDF. So that's one way of doing this. So I could do 1 minus binom CDF, subtract that from 1, and I could say, okay, there's 188 people, okay, 87% of them are right-handed, and what's the probability of 170 out of 188 of them being the sum of that, and then I would subtract that from 1, so let's see what that looks like. So we're going to go, we're going to do 1 minus binom CDF. I'm going to say, okay, there's 188 people in the class, there's an 87% chance to right-handed, and we want to sum up to 170, and that would be about 6%. But that's one way of doing the problem. Okay? And that is actually the most accurate way of doing it. But when we have big models like this, okay, we can use a binomial model. Okay, because in this case, NP and NQ, so NP here, if we're talking about righties, is we have 188 people in the class times 0.87, and then NQ would be 188 times 0.13, and if you do those both out, you get about 164, and you get about 24 here. So both of those are greater than 10, so we can use a binomial model. Well, what is NP? Well, NP is 188 times 0.87, so that's about 164, and that would be our mean, and our standard deviation would be the square root of NPQ, which is the square root of 188 times 0.87 times 0.13. And if you do those out, you get about 4.61. So again, there's 170 right-handed desks, so the 171st person who comes in has to sit down at a left-handed desk. So 171, we're doing a z-score, minus 164 over 4.61, and if you do that out, you get 1.614. Okay? So what would this normal model look like? Well, a z-score of 0 means that there's 164 righties there. So if I go 1.614 standard deviations to the right, okay, that means that that's the 171st righty, and we're going to shade to the right because there's more than that. All right, and then we would just do norm CDF. And we would do 1.614 to 99. And if we do that out, let's see what that looks like. And we get like 0.053. So, well, Mr. O'Neill, why is this 0.06 and that's 0.053? Because this is an approximation. It's reasonable, okay, but this is an exact answer. This is an approximation, okay? Both of them are acceptable.